Hello and welcome to another episode of Psychology
Revision.
Yeah. Today is the first part of stress, and we're going to do stress as a bodily response and stress and the immune system, aren't we?
Yes.
I'm Will.
And I'm Sarah.
I am the brain box of this outfit, and Sarah.
My name is Sarah.
Sarah is the radio face / voice. Right. We're going to kick off with the first pathway that you need to know for stress as a bodily response. Which is, of course, Sarah's doing a yawn, and Sarah is going to explain this. It's HPA. Go!
Okay, firstly, it starts off in the hypothalamus. In the brain to text the stressor. This is stimulated by the pituitary gland, which releases ACTH.
Not AT. I'm not even going to confuse you. ACTH.
This stimulates the adrenal cortex to release hormones called corticosteroids in the blood.
Hey, that's adrenal cortex. I'm sorry that I missed it.
This leads to an increase in the breakdown of fats to sugar, suppressing the action of the immune system, giving you energy.
To sum up, hypothalamus, pituitary gland, adrenal cortex, and energy. Yeah. Right. Now I'm going to do the SAM, Sam, not to be confused with Maddie. You begin with the hypothalamus, which detects the brain stressor again. Then the sympathetic branch of the ANS, sympathetic branch of the ANS sends out nerve impulses. This stimulates the adrenal medulla to release adrenaline and noradrenaline. This increases the activity of the sympathetic ANS, which is basically the fight or flight response. This causes an increased heart rate, blood pressure, breathing rates, and muscle tension, which is all lovely and dandy. I love that word. The body's response to stress.
The ANS has two branches. The sympathetic branch, fight or flight, or the parasympathetic branch, which is just the opposite. When a stressful event happens, the SAM and the HPA are activated. When the stressor has ceased, the parasympathetic nervous system will activate to restore balance.
Now, you can know general adaptation syndrome, which is the alarm stage, the resistance stage, and the exhaustion stage, but that really isn't at all going to be... You're not going to be asked, and so you might not know about it, so we're not going to really do it. Next, stress in the immune system. Stress suppresses the activity of the immune system, and there have been many studies to demonstrate the negative effects of stress on the immune system. For example, the first one, which is on animal studies, and Riley. You can do the procedure.
The procedure. Riley placed mice on a rotating turntable, and he measured the mice's lymphocyte count over 5 hours. The link between stress and tumour growth was studied by implanting cancer cells in the mice. Group 1 were placed on the rotation timetable for 10 minutes every hour for 3 days, which was the high-stress group. And group number 2 weren't placed on the timetable, so turntable, which meant they were the group of no stress.
The findings were that there was a marked decrease in the number of lymphocytes on the mice on the turntable, I believe.
Yes.
Yeah, yes. Lymphocytes are white blood cells, I think, to do with the immune system. Anyway, the tumour stopped growing in the group 2, but increased size in group 1. This shows that that in the no-stress condition, the immune system of the mice were able to control the growth of the tumour. That's the findings. The evaluation. This is convincing evidence as it shows that the reduced number of lymphocytes does affect the ability to defend against disease. It is a lab experiment, so we can infer cause and effect. However, this study uses mice and therefore might not generalise to humans. However, similar effects have been found in human studies, such as the one that Sarah is about to explain.
Human studies. Kiecolt Glazier?
Kiecolt Glazier.
Kiecolt Glazier.
Procedure.
The procedure. He compared the rate of wound healing in a high-stress group of women who were caring for relatives with Alzheimer's disease and the control group of women who were not carers. He used matched matched participant design, and the two groups were matched on their age and income, but not marital status. The participants were given a punch biopsy of 3.5 millimetres just below the elbow, and the levels of cytokines were measured related to immune response. They were also given a 10-item perceived stress scale to determine how stressed they were, how stressed they actually felt.
The findings were that the complete wound healing took significantly longer in the carers than in the control group. It took an average of 9 days longer to heal, if you want to be specific. Cytokine levels were also lower in the carers, and they scored higher on the perceived stress scale. The conclusion you can come to is that this study shows that in humans, stress can also affect functioning of the immune system. Evaluation. Go.
The implications for treating people with infections, examples like when they're recovering from surgery, reducing the stress could increase the speed of their recovery. The participants were matched exactly as
weren't
matched exactly as more of the carers were married and non-smokers. However, both of these should lower the levels of stress, which therefore further strengthens the findings. But this experiment was biased as the participants were female and carers.
Sexist pigs.
And it was a natural experiment, so you can therefore not infer cause and effect.
One supporting study looked at the functioning of the immune system in husbands who had just lost their wives to breast cancer. The immune system functioned less well after bereavement. Another supporting study looks at the effects of stress on the medical students taking exams. Levels of T cells dropped during the exam period. And the final supporting study studied the effects of stress on catching infectious diseases. They found people with a higher PSI, that's psychological stress index, were more likely to catch a cold. And that, my friends, is it. That is stress in the immune system and stress as a bodily response. Thank you for listening. Goodbye.